Alright, welcome to 8.3, similar figures and scale drawings. We just did solving proportions. The next thing you have is a quiz, and then we're going to talk about slope, which is a ratio, so that's good. So today we're going to be able to solve proportions that involve similar figures and solve proportions involving scale drawings. So we have two vocabulary words. We have similar figures and scale drawings. So if you go to your vocabulary, your S's are all filled out already. Well, they're not all filled out, but they're all there. So at the bottom we have a bunch of these S's. I should have done another S page apparently. So we have similar figures and scale drawings. So I have that on the back on that extra page. If you're running out of spaces there, you can use the second extra page. So you have similar figures and scale drawings. So similar figures are two figures that have the same shape but are proportional. Okay, so that just means like either we like zoomed in or we zoomed out. Okay, so these are almost the exact same. It just looks like they just got smaller. Okay, in real life that'd be like getting an adult shoe in size 5 and in size 9. They look almost exactly the same, just one is a little bit smaller than the other. Okay, so shoes are like similar figures if they're the same kind of shoe. Okay. Okay. Scale drawings are a drawing that is enlarged or reduced, and these are all really real life. So personal connection, I just drew an arrow. Oh, excuse me. Okay, so like maps or a picture in a presentation, or if you like zoom in or out of a picture. So when you zoom in or out, it creates a similar figure or scale drawing. Okay, so a map is a scale drawing because if you look at a map of Minnesota, that's not actually how big Minnesota is. It's taking Minnesota and shrinking it down. Okay? Alright, so here we go with the rest of our lesson. Okay, so first thing we're going to do is solve these proportions just to remember how to do that. So in this one, our x is in the numerator, so all I need to do is I need to multiply both sides by 3. So remember in our calculator, here this just gets x. So in our calculator, we just do 3 divided by 7 times 3. So I use my calculator. I'm going to do 3. I'm going to turn it on first. Un momento, apparently. Sorry, I thought it was on. Hanging out, wasting time. Waiting for a calculator to turn on. Sorry. So I'm going to do 3 divided by 7 times 3. That's what we're going to do. So 3 divided by 7 times 3. What's this goes? Sorry. I apologize for this time that you are not doing anything. Just watching my calculator turn on. There we go. Okay, so 3 divided by 7 times 3. So 3 divided by 7 times 3 is 285 thousandths about, or 28,571 10,000ths. So 1 and 28,571. Okay. In this problem, our variable's on the bottom, so before we solve it, we're going to flip it. We're going to use the reciprocals. So I'm going to put 3 over 8 equals n over 2. Now to solve, I'm going to undo multiplying or dividing by 2, so I'm going to multiply both sides by 2. So in my calculator, I'm going to do 3 divided by 8 times 2. So 3 divided by 8 times 2, and I get 0 and 75 hundredths. Okay, so now we're going to do that in real life, using some real life examples. So here we have similar figures. It says that the following figures are similar. Find the missing side. So the first thing we want to do is set up a proportion that involves the unknown. So I'm going to start with the x. X is here. So I'm going to say x over. Now I'm going to compare it to which side over here lines up with the x. Okay, and x here lines up with this 10. So I'm going to say x over 10 equals. Now I can pick any other side over here, doesn't matter which one. I'm going to use 20. So I'm going to say 20 over. Now the number over here, I'm going to match it with 20, matches with this one, 4. Okay, so notice I went from right to left. So I picked right over to left. Okay, because this one is just a little bit bigger, they're the same shapes, so we need to figure out how much bigger it is. So I'm going to undo dividing by 10, so I multiply both sides by 10. So I get x equals, and I'm going to do 20 divided by 4 times 10. So 20 divided by 4 times 10. And I get 50. Okay, so x equals 50. And that's it. Okay, same thing here. The following figures are similar. Find the missing side. So again, I want to start by setting up a proportion. I'm going to start with x. Okay. Now this time I have to think this is x here. Okay. So I got to figure out which one over here is x, and I think I see this really, really small side, and it's across from that small side. So here's my really, really small side, and I have to think this has to be across from the small side. So this line here matches with this line here. So x goes with 9. Now I can pick any number over here I want to. I'm going to pick this really small side because I think that one's easier to reuse. So I'm going to say 12 over, and I'll go back to this one, and 12 matches with 1. So this time I started on the left side and I went to the right side. So I went left to right. Okay. So now to undo dividing by 9, I multiply both sides by 9. So I get x equals, and I do 12 divided by 1 times 9. And if I know my math, 12 divided by 1 is really just 12. So I could just do 12 times 9. So 12 divided by 1 times 9, and I get 108. So x is 108. All right, 2 more examples. Now we're going to go on to scale drawings. Okay, so it says the Chrysler building is 1,050 feet tall. Abdul built a scale model of the building. How tall is the model if you use a scale 3 centimeters equals 35 feet? So we're going to compare centimeters to feet. Okay, so I know that 3 centimeters is 35 feet equals, okay. Now the other number I have here is 1,050, and that's feet. Feet go on the bottom. Okay, so I'm going to put that on the bottom. 1,050. I'm trying to figure out how tall is it in the model. So he's like making it like out of Legos maybe. Okay, so at numerator, the unknown is in the numerator, so now we solve. So I'm going to multiply both sides by 1,050. So in my calculator, I'm going to do 3 divided by 35, then times 1,050, and I get 90. So 90 is equal to x, but this time it didn't say x in the problem. There is no x, so I have to think, what does 90 mean? It was how tall is the model, so it was 90, and it was in the top part, so 90 was centimeters, so 90 centimeters. Okay, last one. It says on a map the scale's 4 centimeters equals 25 kilometers. Now in your homework, it's going to say this as 4. Can you see that? Nope. 4, whoops. cm colon 25 km. That's the same thing. Okay, it's just using it as a ratio instead of using the equal sign, okay? Autumn measured the distance between Duluth and St. Cloud, and it's 34 centimeters. How far apart are they? So we're comparing centimeters to kilometers. So centimeters to kilometers. So km for kilometers. Okay. I know 4 centimeters is 25 kilometers. So 4 centimeters over 25. Okay, equals. Now my other number I have is 34 centimeters. So that's going to go on the top. That means my unknown is x. Okay, but we want the unknown to be in the numerator, so what we're going to do is we're going to use the reciprocal, so we're going to switch this around. It's going to have 25 over 4 equals x over 34. So just instead of having centimeters on top, we're actually going to use kilometers on top, or kilometers, and centimeters on bottom. Okay, that's what we're using. Okay, so we're going to multiply both sides by 34. I'm going to use a calculator. So So I'm going to do 25 divided by 4 times, whoops, I have some parentheses in there, 25 times, nope, divided by 4 times 34. And that gives me 212 and 5/10. So 212 and 5/10 equals x. Okay, but x was in the numerator and we switched it so kilometers was on top. So 212 kilometers. Okay, to solve problems involving similar figures, or scale drawings, we can write and solve a proportion. All right, and that is it.